Hey guys, welcome back to School-Wide Learning. Last week we talked about coordinate geometry. This week we're talking about plane geometry, so lots of angles, triangles, lines, all that fun stuff. So let's get right into it. Okay, so first, angles. Remember, two angles that form a straight line or three angles that form a straight line always add up to be 180 degrees. Other things to remember about angles: vertical angles, or angles formed by two intersecting lines, are always equal to each other and across from each other. That's really helpful to remember when taking the ACT. Other things to remember about angles. We talked a lot in geometry about parallel lines in a transversal. So we have alternate interior angles, alternate exterior angles, corresponding angles, and then we also talked about same side interior or consecutive interior angles. So the trick here is that almost all of these are congruent to each other. The only ones that aren't congruent are the consecutive interior or same side interior angles, and those add up to be 180 degrees. So when in doubt, just set them equal to each other and hopefully you'll get the right answer. Triangles. So there's all kinds of special triangles. First, we have isosceles triangles, which has two congruent sides, which leads to two congruent angles. Then we have equilateral triangles, where all three sides are equal to each other and all three angles are equal to each other. If the triangle's equilateral, each angle is 60 degrees. The other really important thing to remember about triangles is that if it doesn't have any special properties like an isosceles or equilateral, all three angles will always add up to be 180 degrees. So then we talk about special right triangles, which have these formulas we can remember. If you can't remember the formulas and want to solve for a missing side or a missing angle, it's still safe to use trigonometry, but sometimes these triangles are helpful to remember the formulas for. Okay, so just a couple other special formulas about triangles. The Pythagorean Theorem only works for right triangles, and remember, a squared plus b squared equals c squared, where c is always the hypotenuse. So on to polygons. The ACT loves to ask questions about interior angles of a polygon. You might remember the formula n minus 2 equals 180. That's the interior angle sum formula. N minus 2 equals 180, where n is the number of sides. It's really helpful if you can remember it, but if you can't, you can always just draw triangles from one vertice of the polygon, and then however many triangles you have, multiply that number by 180, and that'll give you the interior angle sum of a polygon, any polygon. Circles. So we're going to talk about circumference of a circle, area of a circle, sector area, and arc length. All four of these are related, obviously because they have to do with circles, but circumference is the perimeter around the circle. Its formula is 2 pi r. It's related to arc length, because the length of an arc is also part of the perimeter, just not the whole thing. So if I can remember 2 pi r, I take the angle of this area of the arc and divide it by 2 pi or 360, whether I'm given radians or degrees, and then multiply it by 2 pi r, and that would give me just that part of the perimeter of the circle. The same thing works with sector area. I'm going to take the angle of the sector that I'm given, divide it by 360 or 2 pi, depending upon whether I'm given degrees or radians, and then multiply that by pi r squared. And that'll give me the fraction of the circle of the shaded area. Volume formulas. There's no trick here. There's all kinds of formulas for finding volume. My best advice to you is just break it down into pieces that you know. Obviously, you could find the area of a rectangle and then multiply it by the height. So don't stress yourself out about remembering hundreds of formulas for volume. Just do the best you can and break it down into pieces that you already know. And I think that's going to be all for week 14 of School-Wide Learning. See you next week when we talk about trig.